We're entering 2026, the most consequential year yet for SpaceX's Starship program. The company must land an uncrewed Starship on the Moon before December 31st, meeting a contractual requirement that determines whether NASA's crewed Artemis 3 mission can proceed in 2027. How does SpaceX plan to achieve this? And can they really pull off something this complex with everything that needs to happen first? Let's dive right in. SpaceX finds itself in an uncomfortable position. The company that revolutionized spaceflight with reusable rockets now faces serious doubts about whether it can deliver on its boldest promise yet. Internal NASA documents and external assessments paint a sobering picture. Some analysts believe SpaceX may only manage an uncrewed Starship mission in 2027, with the first crewed landing slipping to 2028 or beyond. That's a problem because NASA's Artemis 3 timeline doesn't have room for delays. Political pressure is mounting, international competition is intensifying, and the agency made commitments it can't afford to break. What's really at stake here? It's not just SpaceX's reputation. If Starship fails to prove itself in 2026, NASA might have no choice but to look elsewhere for Artemis 3. That's why this year has become make or break. The clearest proof SpaceX needs to deliver is launching a dedicated Starship HLS prototype between early and mid-2026. This isn't just another test flight, it's the hardware that will eventually touch down on the lunar surface. The timing matters because it creates breathing room for system checks, integrated testing, and most critically, fixing problems when things go wrong. And with something as complex as Starship HLS, problems aren't just possible, they're guaranteed. But here's where it gets interesting. Launching the HLS prototype alone won't silence the critics. SpaceX must also demonstrate a sequence of capabilities that build on each other. Proving Starship isn't just experimental hardware, but an operational transportation system. Think of it like building a case in court. Each piece of evidence strengthens the argument, but miss one critical element and the whole thing falls apart. The first major test comes in Q1 2026 with Flight 12, validating the extensively upgraded V3 design. This mission carries enormous weight because it will reveal whether SpaceX has actually solved earlier issues or just created new ones. Hot staging improvements, redesigned grid fins, enhanced engine performance, upgraded catch hardware, improved heat shield durability, and the on-orbit refueling system. All of these upgrades face their first real-world validation. Here's my analysis. Flight 12 is arguably more important than any Starship flight we've seen so far. Why? Because everything that follows depends on V3 working as designed. A successful flight accelerates the entire 2026 roadmap. A problematic flight compresses already tight timelines and forces SpaceX into reactive mode. The fact that SpaceX is targeting late January or early February, while officially calling Q1 the window, tells us they've built in contingency time. That's smart risk management, but it also shows how much pressure they're under. Once V3 proves itself, SpaceX faces a relentless sequence of milestones. Reaching orbit comes first. Basic, yes, but absolutely foundational. Without reliable orbital insertion, nothing else matters. Then comes deploying real payloads, and this is where the strategy gets clever. Starship will launch Starlink 5 3 satellites, potentially 50 at once. These satellites are specifically designed to exploit Starship's unprecedented payload capacity. But why does satellite deployment matter for lunar missions? Because successfully delivering cargo to orbit proves the same systems needed to deliver cargo to the Moon. Every Starlink launch becomes a dress rehearsal for lunar operations. It's not just about making money from satellite internet. It's about proving operational reliability that translates directly to NASA's requirements. Recovery and landing represents the next critical capability. SpaceX's entire business model depends on full reusability, but there's a deeper connection to lunar missions. The guidance, navigation, propulsion, and structural systems required to land Starship safely on Earth are fundamentally similar to what's needed for landing on the Moon. You can't credibly claim you'll land on the lunar surface if you can't consistently land at home. Then comes the real technical challenge: orbital refueling. This is where skeptics have the strongest argument. For Starship to reach the moon with sufficient payload and safety margins, it must be refueled in orbit. That requires multiple launches, precise rendezvous operations, successful docking, reliable fluid transfer, and flawless coordination across multiple vehicles. Its choreography at orbital velocities with zero margin for error. SpaceX plans initial refueling tests around mid-2026, starting with 2 starships demonstrating rendezvous and connection capabilities. Early tests will focus on proving the mechanical and fluid interfaces actually work. Later tests must demonstrate repeatability because a single lunar mission might require dozens of refueling flights. Can SpaceX really master this technology in just months? The honest answer is we don't know, but they've surprised skeptics before. What's particularly smart is SpaceX's parallel development of a dedicated propellant depot. Instead of requiring freshly launched tankers to immediately transfer fuel, a depot can store propellant and centralize operations. SpaceX has already completed depot power module demonstrations and activated a hardware-in-the-loop test bed using flight representative hardware. That's not just planning, it's active development of critical infrastructure. While flight testing progresses, ground infrastructure is expanding rapidly. Pad 2 at Starbase nears readiness for V3 operations. Pad 1 requires upgrades to support 2-stage landing operations and should return to service in the second half of 2026. In Florida, LC-39A is being upgraded for higher launch cadence, while SLC-37 progresses toward 2027 operations. This geographic distribution isn't accidental. It creates redundancy and operational flexibility that single-location operations can't provide. Production capacity represents another crucial element. The Star Factory is expected to reach full operational capacity in 2026, becoming the world's first mass production facility for orbital-class rockets. Combined with the new Gigabay coming online around Q2, SpaceX will have 3 megabays capable of assembling multiple starships simultaneously. That's not iterative improvement, it's industrial-scale transformation. Here's what often gets overlooked. Production bottlenecks don't just slow progress, they eliminate options. When you can only build one vehicle at a time, every failure sets you back months. When you can build multiple vehicles in parallel, failures become learning opportunities without catastrophic schedule impact. That's the real value of mass production capability. Testing infrastructure has proven to be a critical bottleneck. Issues with Ship 39 and Booster 18 exposed weaknesses in test flow and facilities. SpaceX has implemented substantial upgrades throughout 2024, and 2026 will see further expansion aimed at achieving reliability suitable for operational scale flight rates. This isn't glamorous work, but it's absolutely essential for transforming Starship from prototype to operational system. Then everything changed with a White House executive order titled Ensuring American Space Superiority. The document explicitly states the U.S. will return Americans to the moon by 2028 through the Artemis program, not 2027 as NASA previously announced. That single year makes all the difference. Elon Musk's response was simply, cool. Why would he react positively to an apparent delay? Because it's not actually a delay. It's a realistic timeline that gives Starship the time it needs to succeed. The 2028 deadline still positions the U.S. ahead of China's stated 2030 goal, while allowing SpaceX to properly develop and validate critical systems. The orbital refueling system won't even begin construction until mid-2026. Rushing an uncrewed HLS mission before these systems are ready would be reckless. Here's my assessment. The shift to 2028 is politically brilliant and technically sound. It removes pressure for premature launches while maintaining strategic advantage over China. It also signals the White House is protecting SpaceX's central role in Artemis, rather than forcing disruptive competition. SpaceX could still push for an uncrewed landing in early 2027 and crewed by mid-2027, but now they have flexibility instead of facing impossible deadlines. What's even more ambitious is the moon base requirement. Initial elements of a permanent lunar outpost by 2030. That's just 2 years after the first crewed landing. Traditional approaches would make this impossible, requiring countless missions to deliver modules that must be assembled on the surface. But what if Starship itself becomes the base? A fully outfitted Starship could launch with expanded life support, habitation, and research systems, then either transition to horizontal position using cushioning systems or execute a controlled horizontal landing. Suddenly, a 2030 moon base becomes achievable. Even if Starship isn't used as the base structure, its payload capacity makes delivering massive modules and heavy equipment on accelerated timelines entirely feasible. This is where Starship's design philosophy, maximum payload, full reusability, rapid turnaround, transforms from impressive engineering to strategic game changer. Recent progress at Starbase confirms SpaceX isn't just planning, they're executing. Test Tank 39.1 is being transported to prepare the Massey site for Ship 39's cryogenic testing. Booster 19's forward section, featuring the updated hot staging area and grid fin openings, has been delivered to Mega Bay for stacking. If B-19 reaches structural completion before December 24th, it will be the fastest booster build ever, surpassing all previous records. This acceleration matters because it demonstrates SpaceX's determination to maintain momentum despite B-18's failure. They're not slowing down, they're speeding up. Meanwhile, Europe just reminded everyone that this space race has more than two players. On December 17th, Ariane 6 successfully launched from French Guiana, carrying 2 Galileo navigation satellites into orbit. After years of depending on SpaceX following Ariane 5's retirement and losing Soyuz access, Europe can finally launch its own missions again. This was Ariane 6's 5th flight and 4th success. Meaningful progress after a difficult development period. But here's the reality. Restored independence and actual competitiveness are different things. Ariane 6 now faces the challenge every space program confronts, increasing launch cadence while dramatically lowering costs in an industry where SpaceX has fundamentally changed what's possible and what customers expect. So what's the real story here? 2026 will determine whether SpaceX's Starship becomes a transportation system that opens up the solar system or remains an ambitious experiment that couldn't deliver when it mattered most. Flight 12, Orbital, Refueling, payload deployment, the HLS prototype launch, and ultimately that uncrewed lunar landing. Each milestone builds the case that Starship works. Miss any of them, and NASA's entire Artemis architecture faces serious questions. The stakes extend beyond corporate competition or national pride. We're watching the foundation being laid for permanent human presence beyond Earth orbit. What SpaceX achieves or fails to achieve in 2026 will shape space exploration for decades. What do you think? Can SpaceX actually pull this off? Drop your thoughts in the comments. If you want to follow every development in this critical year, hit that subscribe button and join Space Update 24 hours. Like this video if you're as invested in this story as I am. Thanks for watching, and I'll see you in the next one.